Fine. So covalent bond is something that can be generally formed between a metal and between a non-metal. Correct. But the question is that what is that is an interpretation. Now the question is why? Do you know why?
Because it shares electron. It is formed by sharing electron.
Fine. So sharing of electron is it has been also found in case of the ionic bond.
Yes, sir, but sir, it deals with the valences up to 5, 6, 7, and 1, 2, 3, but not with the 4. 4 is an exceptional case.
But not getting the appropriate point. See, the basic difference between ionic bond and covalent bond is that activity let me share it. Yeah. Can you see the board? Is my screen visible?
Yes, sir.
Board is not connected. So as we have told that in case of the covalent bond, the metals and non-metals, two non-metals, basically non-metals and non-metals, right? And in case of ionic bonding, we have find that it's between the metals and non-metals, correct? Right? Like we can see the example of H2O in case of covalent bond, is it not? Or CH4. In case of ionic bond is that
NaCl,
yes, NaCl and
correct.
MgO,
MgO.
But in case of the covalent bond, there is CaO, calcium oxide. No, is it? No.
No, sir, no.
CH4,
CCl4.
CCl4, something like that. So basically what happened, the higher electronegativity differences is responsible for ionic bonding. Okay. And here in case of covalent bond, we can find there is a lower or lesser electronegativity differences. Are you getting it? Lesser electronegativity differences. That is the main reason why this bond are forming covalent bond and ionic bonds. Okay. Note it down in your copy. Done? Now, syllabus is that carbon with compounds is there and covalent. So let us start out the covalent compound. Literally, we'll get to know about the carbon and all things. Yeah, because this is a very easy part, so we'll get to understand. This is up to this part. This is very easy part, but covalent bond is something that is given in your syllabus. So that is the thing you should know. Carbon and its compound. So let us have a discussion on that.
In the previous video, we got introduced to the versatile nature of carbon. Can you tell me why it is capable of forming so many bonds with so many
So
elements
increase
around?
the sound.
To know this, let's have a look at the atomic structure of carbon first. Does the atom look somewhat like this? Yes. To know this, let's have a look at the atomic structure of carbon first. Does the atom look somewhat like this? Yes. The electronic configuration of carbon is 2,4. That means it can either donate or accept 4 electrons to achieve stable state. However, it's not as easy as it seems. This is because donating the 4 electrons will mean that the atom is now left with only 2 electrons. But the number of protons still remain the same, right? That means the atom will gain positive charge and will still be unstable. Similarly, accepting 4 electrons will also lead to a situation where the carbon atom becomes negatively charged. Thus, both the situations would lead to instability of the carbon atom. So the option that carbon adopts is to share electrons. Sharing in carbon can take place up to 4 electrons. That means carbon can share all its valence electrons with any other atom. We know that such sharing of electrons leads to a special type of bond formation called the covalent bond. So to understand carbon chemistry, we need to understand covalent bonds first. How can we define a covalent bond, by the way? In simple words, it's the bond formed between atoms by the sharing of electrons. Now the next question that pops up in our mind is how many electrons need to be shared to form a covalent bond? Is it 1 electron or a pair? Or more than a pair? Can you guess? Let me help you with the answer. When we say sharing, it means that both the atoms need to contribute for the bond formation, right? It indicates that each atom will give at least 1 electron from its valence shell. Does that tell us that a covalent bond will involve minimum of 1 pair of electrons? Yes, a covalent bond needs at least 2 electrons or simply 1 pair of electrons. Such a type of covalent bond where 1 pair of electrons is shared between the atoms is called a single covalent bond. It is denoted by drawing a single line between the 2 atoms. A simple example that explains this type is the formation of a chlorine molecule. How do you think this molecule was formed? We know that chlorine has 7 electrons in its outermost shell. That means only 1 electron is needed by it to complete the octet. Now here's another chlorine atom which again has 7 electrons in its outermost shell. Both of them want 1 electron each. And that is why we find 2 chlorine atoms coming together and forming a bond by sharing 1 electron pair. Now if we look at this orbit individually, it has 8 electrons. And this orbit too has 8 electrons. Stability achieved for the chlorine molecules. This was an example of a single covalent bond. So do all atoms form covalent bonds by sharing a single pair of electrons? Think for a moment. We know that oxygen is in the diatomic state. That means one oxygen atom forms a bond with other oxygen atom to form a stable molecule. Do you know how many electrons are shared in this bond? What do you notice? There are 4 electrons shared. That means both the oxygen atoms contribute 2 electrons each, thus giving 2 pairs of electrons in the bond formation. So is this not an example of covalent bond? Well, it is. But covalent bond has 1 pair of electrons being shared, right? Don't forget, it is a minimum of 1 pair that's needed for formation of the covalent bond. That means this case is also an example of a covalent bond. Such a covalent bond which involves 2 pairs of electrons getting shared is called a double covalent bond. It is represented by 2 lines written between the 2 atoms. Just like this as seen in case of oxygen. Now on the similar lines, can you give me an example where more than 2 pairs of electrons are shared between the atoms? Wait a second. Are we trying to say that a triple covalent bond also exists between the atoms? Absolutely. And the best example to study this is the case of nitrogen. We always find a nitrogen molecule written like this. Needless to say that the 2 nitrogen atoms share a triple covalent bond. That means 3 pairs of electrons or simply 6 electrons are shared between the atoms. This helps both the atoms attain the stable state. Now tell me one thing. Which type of covalent interaction does carbon prefer? Does it opt for a single or a double or a triple covalent bond? Astonishingly, carbon has the ability to form all these types of covalent bonds with different elements. Yes, it can have any of these covalent interactions with atoms of other elements or even with other carbon atoms for that matter. In the next video, let's have a look at how exactly carbon forms bonds.
So nothing is coming. Let's take me reconnect it again. Okay, is the screen visible now?
Yes,
Yes.
Good. So now we try to draw some of the structures of covalent bond, right, in case of carbon and other compounds. And also we came to know about more terms like lone pairs. Do you have an idea about lone pair? What is lone pair? What is lone pair? Do you know? Okay. Can you see the screen, the second page? Not yet. Okay. So now it's been coming. So in case of hydrogen, we can see. So we need to draw with me the hydrogen in a single molecule like this. It's forming of molecule by covalent bond. So how it will distribute? Let's say there is a green dot and another molecule is there. And this electron is donated this. Now it will share it equally. Okay, it will share it equally. So now the hydrogen for one will like this. Okay, this is H2. Are you getting it?
Sir, repeat once again.
So these are the 2 electrons of hydrogen to form this bond, hydrogen bond. Now the question is that in case of other compounds, let us take another example with fluorine. In case of fluorine, you can find how many electrons are there in the last cell? It's 9.
One,
That
one.
means
1, 1.
2, 7.
Seven.
No, 7. Fluorine is 7. So that means 1, 2, 3, 4, 5, 6, and 7. Okay. The last cell we have 7 electrons, right?
Yes.
So now in case of this way, 1, 2, 3, 4, and just 1, 2, 3, 4, 5, 6, and 1, 7. Okay. So now we can draw an arrow, and now again put it down electrons here. 1, 2, 3, 4, 5, 6, 7. And this one also 1, 2, 3, 4, 5, 6, 7. Right? Now they are forming an electron sharing of equal electron. So now they are forming a bond like this. Are you getting it or not? Are you getting it?
Yes, a little bit.
So now draw in the copies.
So that means hydrogen cannot exist alone.
Hydrogen is also doing that, no?
It cannot exist alone.
That's why it's a H2 in form of H2 that is always existing in our environment. That's why why the molecule actually exists. Is it not? So they actually form between the covalent bond and they still stay together in this way. Okay. So there is an example of this hydrogen and fluorine. So now is there another example wherein in these both the cases we have found the single bond. So now we also can found the double bond and triple bond, is it not? In case of oxygen, we have found a double bond. So in case of nitrogen, which is very, very important for your exam also. So how many electrons can be found? The nitrogen can, yes.
Sir, only 2, 5.
5. So now,
That means 3. So triple bond will be there.
yes, now draw it down. Draw it in your copies, how it will look like.
The nitrogen.
Yes. The same way I have drawn the fluorine, molecule of fluorine. If you have got Asian book, the things are given in page number 155, 156, you can find these kind of things. Now moving to the next one. Now tell me one thing. If I am drawing of oxygen, so how many lone pairs of electrons are here? Can you say? So the electronic structure is 2, 6. So I have drawn it three lone pairs. How many lone pairs are here? 3 lone pairs of electrons. This is a very good question. So now tell me, in fluorine, how many lone pairs of electrons are there?
Sir,
Three.
chlorine.
Yes.
Three.
Fluorine, 3. How? It's 2, 7, right? So 1, 2, 3, 4, 5, 6, 7. So again, it's 2 lone pair of electrons. But in case of nitrogen, can you say?
2, sir. 2.
It's 2. Right. Now, all the thing I'm asking you about the molecular in a molecule or in an atom, but when there would be in a compound, the things could have been changed.
Yes, sir.
Like in HCl, can you say how many lone pairs of electrons are present? How many lone pairs of electrons are present here?
Sir, hydrogen and chlorine one only.
Where, sir? Where?
In HCl. In HCl.
1, sir. 1.
One
No,
only.
no, you are not getting it. So before that, you are just let me clear some of the things that then it will become clear to you. So just I wanted to draw oxygen. Let me do that first. Then I'm coming back again. So in case of oxygen, you can find how many electrons are there? 1, 2, 3, 4, 5, 6. So in both the cases, you can find equal number of electrons, that is 1, 2, 3, 4, 5, 6. So now in your book, it has been drawn in such a way: 1, 2, 3, 4, 5, 6, and then
Sir, I
1,
think-
2, 3, 4. In both the cases, you can draw it in this way because it's a equal sharing of electron. That means O11 right?
Yes, sir.
Draw it now. Draw it now. And in case of nitrogen, you can find 2, 5. That means 1, 2, 3, 4, and 5. And again, you can find here 1, 2, 3, 4, and 5. But now I'm telling you, in case of forming triple bond, do not write in this way. Do not write in this way. Okay. So which way we need to write? Let us see that. 1, 2, 3, and 2 electrons are here, plus 1, 2, 3, and 2 electrons are here. Okay. So now, if we are drawing it in this way, 1, 2, 3, and 1, 2, 3. So now when you are doing it, they're equally using the electron, sharing of electron this way. Now you can write it 1, 2, 3. That is okay. Are you getting it or not?
Sir, it's 3 electrons, then N2 has N3.
No, it's not N3. So there are 3 type of bond that has been found in single bond, double bond, and triple bond. But in 2 atoms are there. If 2 atoms are involved here, then we have to write N2. If 3 atoms would have been involved here, then it has been write N3, right?
Okay.
Is this clear to all?
Yes, sir.
So now I'm drawing another kind of thing, that is HCl. So now this HCl coming. So now we are till now we are doing in a same atom like in molecule. Now we are choosing a compound. This is the molecules. This is all molecules. So now we are choosing compounds. So it's a different atom, right? So H plus, and we are taking, let's say, Cl.
Cl minus.
Cl. So how many electrons are there? 1, 2, 3, 4, 5, 6. But only one electron can be involved here. Now in Cl, you can say how many lone pairs of electron are here?
4.
Uh,
No,
Three.
sorry,
Cl 3,
sir.
3.
3. So now in HCl, now what is happening? Let us go through. So H and 1 electron of Cl. Are you getting it? So now they are
Yes, sir.
forming sharing of electron both in this manner. So now HCl. Now tell me
Yes, sir.
how many lone pairs of electrons are present in HCl molecule?
4.
No, it's 3 because it has been bond already. The bond formation is there.
3, sir.
If you can say then these 3 are there. So again the same thing we can write. The lone pair of electron in HCl molecule is 3.
Not understood, sir. Explain again.
Yes. The lone pairs of electrons in HCl molecule. So already we have utilized this one as a bond formation. So it has been already used as a bond formation. So you cannot say the electron is still left. So how many electrons are left here? 6. That means the lone pair of electrons are 3.
Okay, sir, understood.
Okay. So now we can go back to that page where we have written that how many electrons are there in case of HCl. Now we can write here. Again here you can write that the electron are there 3 lone pairs of electron. Is it not? Right? Now are you getting it? Students, are you getting it?
Yes, sir.
So please write with me. Otherwise, please draw with me. Otherwise, you will be able to produce it. If I say that these things has to be produced. So it is look to be very easy when someone is drawing, but you need to draw it in your own way. Just draw it down and show it to me that you have drawn.
Sir,
Sir, in case of variable valency, how will do?
Now, if you are drawing CH4, so how will you do that? So carbon has a 4 valency. Is it not? Carbon has 4 valencies. So if carbon has 4 valencies, so how will draw that?
sir, can I?
Yes.
Sir, it will have the 4 hands, and in the 4 hands, we have to fill the hydrogen.
Yes. So now
Sir,
can you draw
each
something like
hydrogen-
this? Yes.
Sir, will share 1 electrons to the carbon, and the carbon will form the valence.
Like looks like this, right? So now if we put 1 electron, if we put 1 electron is there, so now 4, 1, 2, 3, 4. So now putting all the electrons of hydrogens here, 1, 2, 3, 4, and also drawing the hydrogen atom. Okay. So now we can draw in this way, in this way, in this way, in this way, and finally we can draw this way. So now we can write this is stage one. Tell me, are you getting it or not?
Yes, sir.
Draw it down.
Then how many node pair is there?
How many lone pairs are there? 0. Because there is no electron left here. Is it not? Carbon has only 4 electrons in its last outermost shell. So 2 and 4. So all the 4 electrons are utilized here. So there is no lone pairs of electron, or no single electron is left here. And in case of hydrogen, there is only 1 electron. So there is no way of lifting any kind of electron in hydrogen atom. Done? Completed?
Yes, sir.
So now we are actually we have included in carbon chemistry, right? So now tell me what will happen in case of carbon dioxide or in case of C2H4. So now can you see in carbon dioxide 4 electrons, we are writing in this way, and 2 oxygen. So 1, 2, 3, 4, and 5, 6. So now we can write it down in this way, is that
Sir, I think it will form a double bond.
yes, thank you. So 1, 2, 3, 4, and 5, 6 is here. 1, 2, 3, 4. The same way we can write it here. 1, 2. So 1,
Sir,
2.
can we write carbon and first?
Yes. Hmm?
Sir, CO2, it will, carbon monoxide is different.
Yes, carbon dioxide. We are writing here carbon dioxide.
Okay.
Or draw. Okay, done. Okay, done. Rajak, Ramij, did you
Yes, sir.
complete it? Completed. Husainur, Imran,
Yes, sir.
have
Yes,
you drawn
sir.
it? Have you drawn it?
Yes, sir.
Okay, so now we are getting in another compound that is most important is that in carbon, C2H4 and C2H2, right? So how the formation of C2H4? So again in carbon we have you see something like that at 4H. So I'm not getting it too complicated for you. Keep it simple, like carbon and carbon. Okay, so 1, 2, 3, 4, right? So these are the four want to be uses for carbon. This is a carbon-carbon chain, and carbon, but carbon has 4 wings, right? Carbon again 2 electrons we are keeping here. We are keeping here, and now the hydrogen's part is there. Hydrogen, 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 and hydrogen. Okay, are you getting it? So now what will happen? So now I just down here. This will be easy to understand for you. C double bond C, hydrogen, 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 and hydrogen. Okay, is it clear? Is it clear to you?
Will not show by circling.
You can do the circling, same thing, same way.
Sir, do it, sir.
I'm just not getting it complex for you. That's why I'm not circling. That is the only reason.
Sir, do it, sir.
Okay. So now, in case of C2H4, it's a little bit of complex for you. Just let me draw it again. Achha, I'm circling. Just let me do it another compound so that it is become understood, and then in the next page I'm just doing that. So in case of C2H2, at first doing it. So the name I will discuss it later. So the name is ethylene and acetylene, or ethyl, or it is the name is, you can say, ethene, ethene or ethylene, and it is the name acetylene, but in IUPAC you can say it whatever we have learned today, so just go through with that. In the next class, I will explain it. Okay, so all the covalent structure you need to draw it on your copy, like C2H2, C2H4, and all that. And the Thursday, I will start in more elaborately, and whatever the structure left, I will let you know. Okay, today I am finishing my class.